All right, so let's unpack this. Forget the really complex infrastructure diagrams for a second. Just picture this. You're in a large organization and you have, say, 4 separate live HD video sources. Could be anything. Surveillance feeds, internal training, maybe a news feed from a set-top box.
Right.
And you need to get that content across an entire building instantly.
Okay, but here's the catch.
Exactly. The building's wired with, decades-old copper coax cable.
But people want to watch on their tablets and laptops now.
That's the gap. That's the problem we're diving into today, the bridge between that legacy wiring and modern IP streaming.
And that bridge really is this one device, the Thor Broadcast H-4ADHD-QAM-IPLL.
So our mission then is to figure out how this single box works.
Yeah, how it operates as a kind of a universal translator for your infrastructure. It takes all those different video sources and it converts them.
So you can broadcast on your own custom TV channel using the coax that's already in the walls.
While also, and this is the key, serving it up to your IP network.
And it's doing 3 jobs at once, right? It's an encoder, a modulator,
And an IPTV server. All simultaneously, all in one unit.
Let's start with the inputs then, because the flexibility there is, well, it's pretty wild.
It really is. It can handle 4 separate sources at the same time.
And it doesn't care what you plug in. HDMI, component, composite.
It just takes whatever video language you throw at it. But, the feature that really stands out to me,
What's that?
it's that separate analog input, the one specifically for capturing closed caption 608 data.
Ah, the 608. And that's not just a nice-to-have feature, is it?
No, not at all. For certain clients, it's critical for compliance. We're talking hospitals, schools, government offices.
So they need that legacy captioning support to be compliant.
They have to have it. This box ensures they do, right out of the gate.
Okay, so the signals are in. Now the machine encodes them. You get 2 main choices, MPEG-2 or H.264.
Yep.
Is there a practical difference for the person setting this up?
Absolutely. Think of MPEG-2 as the old, reliable workhorse. It's really stable, super low latency.
So great for live broadcast inside the building.
Perfect for it. Then you have H.264, and that's all about efficiency.
Squeezing more channels into less space.
Exactly. You'd use H.264 when you need to get dozens of high-quality channels onto your IP network without, crushing your bandwidth.
Okay, so we've packaged the video. Now for the magic part, the simultaneous output.
Triple thread, yeah.
It's sending the signal out 3 ways at once. You have RF QAM for the coax, ASI for other broadcast gear, and IP.
And that's what makes it so useful. The QAM, that's quadrature amplitude modulation, it essentially turns your coax cables into an instant digital TV channel.
And any regular TV can just tune it in.
Any TV, no special decoder. At the exact same time, a second network port is handling full IPTV streaming.
So that's feeding the tablets, the desktops.
Right, using standard protocols like UDP and multicast.
So what if I'm, I don't know, an IT director on a huge campus, and I deploy 20, maybe 30 of these? Is that a nightmare to manage?
No, not at all. And that's the beauty of the NMS, the network management software.
So you don't have to walk to every single unit.
No way.
Yeah.
You just access it through a web browser on a dedicated network port, and you can manage, configure, and monitor your entire headend from one desk.
So you can just stack the units and scale up.
You stack them, you connect the RF outputs, and you can build out dozens of channels. It's really that simple.
Okay, so to recap the core value here, you take 4 live HD inputs.
From any source.
From any source, right. You encode them for compliance and efficiency, and then you push them out over your legacy coax and your modern IP network.
Simultaneously.
At the same time.
Precisely. And the real insight is that you get to bypass the single biggest sunk cost in institutional video, which is always running new wire.
You're just extending the life of the infrastructure you already own.
You are. This box takes a massive infrastructure problem and transforms it into a very targeted, simple hardware solution.
So what does this all mean then? It leaves us with a final thought to consider. Given this ability to instantly bridge old coax networks with modern IP streaming, if your systems all rely on that existing copper, how much long-term value is there in a tool that means you can avoid a costly, maybe even a multi-million-dollar rip-and-replace project?